Remember this? Well, it's got a new big brother. Stick around. I'm going to show you what I did. Hey everyone, I'm Scott, Edge of 3D. I'll put my logo up here somewhere maybe. Anyway, you know that. You clicked on the channel. And right now, as of the filming of this, let me switch this over here right quick and show you something. Right here, we're at 4,999 subscribers. That's in real time, so we're getting really close to 5,000. Probably happened tonight. Anyway, back to I've been doing a lot of material testing, and you've seen bits and pieces of the machine that I built. And if you followed the channel for very long, you remember this original machine, which was built with spare parts, old printer parts, dragster, the 3D dragster that we were running at the Rep Rap festivals, parts from that. The only thing I purchased actually was this meter here, and it went right here, and it broke hooks, and obviously I took it off there because this is actually a calibrated meter, and I'm going to show you here in a minute over on the other machine. I used this when I was calibrating that one, and but I'm still going to keep this around, and I'll put the meter back on it and still break hooks from time to time just because it's fun, and I still don't have a trim tab switch on my boat for the left side trim tab because it's here. All right, so I'm going to show you some data here right quick, and I'm working on this. I will eventually share this, but just real quick to go over some data points. The x-axis brake load, that is a piece that's printed laying flat on the bed, and it's loaded to the point where it breaks. And you can see here in the chart, we go from a high of 304 kilograms for annealed PPS carbon fiber down to a low of 116.58 kilograms for my roll of Polymaker Mystery material. It's a roll that Polymaker sent out to several of us a few years back to test. They never did tell us what it was. I like to call it ass material because when it's printing, it smells like ass. Polymaker never did actually put it into production, but I hear a rumor that they're producing it for other people. Anyway, that's a whole other story for another day. But I've got some extra data points. So x-axis brake is the point at, it says brake load, but it's not actually the brake, it's where it yields at, the peak where it yields. So I need to change the nomenclature here on this button. But what it is when you're pulling a piece, it'll have a point where it increases in force, and then all of a sudden it begins to yield, and it'll stretch some more before it finally breaks. On PPS, carbon fiber, it happens so close together that the machine can't pick it up. A layer brake is exactly that. My computer is being slow here. Is exactly that. It's a piece printed standing up using Voron standard, and it's layer adhesion. As you can see, the mystery stuff has some really good layer adhesion, and Polymaker ASA Black has some really good layer adhesion. Direct thread yield, that's a piece that's printed, and it's got a 3mm screw threaded directly into it to a depth of 4mm, and it's pulled till it yields. And like on the mystery filament, I didn't bother with that. Heat set is a heat set insert that is a 3mm thread, 4mm depth, 5mm diameter, It's heated into the part, screwed in, and then it's just pulled until it pulls out or yields. Um, Again, varying results. PPS does really good. ABS does really good for the polymaker, but not so good for KVP, and ASA held on to the heat set really well. Izod, that's the machine that's behind me at the beginning of the video. It's the swinging hammer, and right now it's just a number that's a value of 0 to 100. So if it no load whatsoever and it swings all the way, that would be a very low number. It actually doesn't wind up being 0. It winds up being 12 on here. But for the purpose of this, it's just a comparison number. It's only for comparison. It's not a value. It's not a weight. It's not a joule. Eventually, I will get the code put into my spreadsheet to give joule outputs. But this is just the point where it breaks. And as you can see, PPS carbon fiber doesn't do very good, and natural ABS does really well. The higher the number, the stronger the material. So here's the 2 data points that this new machine gives. And this is the x-axis yield point, and we'll get over to the machine in a minute. I'll show you how I do it. But I preload it, 0 it, and then I pull it, and at the point where it yields, it peaks, the machine records that value. And then as it goes on until it breaks, it records the distance at where it broke, and this is in millimeters. So let's jump over here to the bench overhead, and I'm going to apologize. It's a mess. And, of course, there's glare off the overhead lights that get on everything here. So I'll move that back a little bit and eliminate the glare off the screen. And nothing's... It's still in the building phase. It's still very much a work in progress. I originally built this with just 2 geared regular stepper motors, and it didn't work out real well. I was overloading them, so I went to this stepper online closed loop stepper. I'll post a link to it in the video description down below. It'll be my Amazon link, but it'll also give you the specs on it. And then I got a gear reduction for it off of AliExpress, I do believe. I'll put a link on there, and that obviously won't be. The gears are printed. They're printed out of a polymaker nylon. I think it's PA6. All these parts here are machined on my Milo mini mill. I'll throw a link to that, or I'll put a link to the series where I built the Milo mini mill, but I mill all these myself. And then like this test piece here, I've milled it myself. We'll get into this in just a minute. What the machine does is it measures, because it's a closed loop stepper, it measures distance. I know how much the distance is on the lead screw for each revolution, and it's all calculated in there. And on the screen here, it might be a little hard to see, but the distance right now is at a -1, and that's from my 0 point. No force. The last thing I broke peaked at 85.2 kilograms at 0.75 millimeter, and that was actually a layer test. So we'll just go ahead and do another one right quick, and I'll show you how it does. So I have a button I hit here that zeroes everything out. It'll always have a little bit of force on there because, as perfect as I try to make this, any load on it at all, it creates a force, but it's under 1 kilogram. And what I've started doing is I load everything to 5 kilograms. So I hit this, and you'll see the machine starting to load. You'll see the gears turning here. And you'll see this, and when it comes up to 5 kilograms, it'll stop. It's going to take a minute because it's starting to put some force on it now. There we go. You can see the climbing. It's at 5 kilograms now, and it stopped. When I hit the button again, it's going to zero the distance, and it's going to go ahead and pull it till it breaks. Now, this is a layer adhesion. It's a ABS, So it's probably going to snap somewhere around 80 kilograms, 89.4. And at 0.79 millimeter, and then it shows the break at 0.825. And did it really yield? And also, this is also printed solid. I screwed these up. That's why they're not part of the testing. They're printed solid. So that's how we get the values on this. Now, I'm going to show you what I really designed it for, and that is testing these right here. And that's a PPS carbon fiber. That's not a good one to test because it's just going to snap. So let me grab an ASA over here. Here's some natural ASAs. It's Polymaker ASA, and it's natural. It's got no pigmentation in it. So it's back to a -1. I'm going to zero everything out. That's probably not going to drop in there, so I got to unload it some more. And I've got a button I hold, and it just backs it up slowly until I can drop the part in. These were actually ones I was printing while I was calibrating a new extruder and hot end on the Voron, so it's got little pieces that stick out. So they're not really valid for testing, but they work great for showing you on this because obviously these little pieces sticking out can, hang up in there. So the 5 kilograms of force preload makes sure that, it's not going to take 5 kilograms of force to smash that. So I'll go ahead and zero everything out, hit the preload. And if you watch here, it's preloading up to 5. It'll stop. Now, when I hit this again, it zeroes out the distance, and it starts from a 5 kilogram preload, 0 millimeters, and then it starts loading. And you'll see as it's counting up here, there's 1/10 of a millimeter, 2/10, 3/10. You'll see the force climbing, 17, 18, 20, 25 kilograms. This is probably going to go up in the mid 100s before it breaks. But you'll see what happens first is we'll get a yield value here. And that'll be at the point where it peaks out and it starts to yield and let it stretch. All right, it looks like it yielded around 175.8 kilograms at 3.02 millimeter, and then it went ahead and pulled it until it broke at 3.315 millimeters. So we'll do one more just for fun. We'll actually go ahead and break this PPS carbon fiber piece because PPS carbon fiber is really fun to break in here. I have one right here that someday when I get brave enough, I'll put in there. This is probably going to take upwards of 700-800 kilograms of force to break it. So let's go ahead and we will break a PPS carbon fiber, and you'll see it's a lot more violent break when it goes. The slow motion camera, it's absolutely amazing when it catches in slow motion, the sound that it makes. So we'll get it preloaded up here. All right, there's our 5 kilogram preload, and let's break it and see what it does. There's 100 kilograms. There's 200. I'm going to say we're going to get a break right around 300. I'm going to step back. There we go. 284.6 at 2.62. And as you can see, the yield and the break happened at the same time on this material. 2.62 and 2.649. So, I mean, that was literally probably one step on that stepper for that distance. But there you go. There's a PPS carbon fiber break. And let's see if I have a heat set or not heat set sample here. Okay, so here's an ASA natural. What I do is I have that marked at 4 millimeters, which that's the depth of threads on a heat set. Obviously, if I thread it in deeper, it's going to hold harder or hold more, but I want to compare apples to apples. So I screw that into the 4 millimeter mark, drop that in there. We'll zero this, we'll preload it. And really the distance on here for the yield and all that is insignificant. It's just at the point where it yields at is where the threads give out. So the main thing I use the distance for is testing on the x-axis strength. It's going to take it a minute to get there. Okay, we should see our 5 kilogram load coming here any second. And there it is. So we'll go ahead and start it. And this is just direct threaded into ASA natural. Has no pigmentation in it. It's just natural ASA, whatever the blend is the polymaker uses to make these. And you can see it peaked at 49.8 kilograms is where it gave out at. So 49 kilograms of force on that thread there. So finally, the original tester off of this machine here. Remember that set there and it had a hook here and eye there, and we put the hooks in it and broke it. You know, it's got a 50 kilogram limit. So what I did is I printed these pieces here. I don't even remember what material they're printed in. And this is designed to set in here. And right now the machine's way too close together, but that's set down in there, and then 2 screws. Take these out, 2 long screws through there. And then I very slowly loaded this machine up and used that to calibrate my load cell and put all that into my sketch. That way I've got a calibrated load cell. This load cell here matches this here. So it's not any kind of a standard. It's just my standard, which, as I've said before, my standard that I use is TLAR, which that looks about right. So that's it. That's the new testing machine. That's a sneak peek at the program that I will have. I will link to it in my videos, and as I test each material, I will add these to that, and we'll just jump back over there for a minute. And one of the other things that I've added in here is a comparison view, so you can go in here and you can pick. One of the things people always is colors. So I've tested Polymaker Natural, Polymaker White, and Polymaker Black. Now the annealed, we'll talk about that at a later date. That was an experiment that'll be coming off of this chart after we talk about it, because annealing ABS did absolutely nothing. But here we got our Polymaker Black, Polymaker White, and Polymaker Natural. And you can see right here the differences. Everything was printed on the same exact machine with the same settings, and the Natural had the strongest material strength on exit layer. White was the lowest, black was middle of the road. Yield point. ABS yielded at the lowest number, but had the highest. So it held a lot stronger till it let go, and then it let go at a lower number. So black in the middle, white stretched the furthest as it yielded. X-axis where it actually broke at, 3.34 on the natural, 3.6 on white, 3.46 layer adhesion. Black had the highest layer adhesion. Natural had the lowest. White was in the middle. Direct thread, black did the best. Heat set, black did the best. Eyes on shock, natural did the best. And just to show you here, all of my tests are sets of 5. So here's everything recorded. I do five tests of each item. So 5 and 5 on every one of them. And then if I have a really bad outlier that's more than about 15% out of line with all the rest of them, I will just remove that from the test, because it could be who knows what. So each chart, blow these up a little bit, make them a little easier to see. So you can see each chart here. Again, 5 of each. The mystery stuff, I didn't do direct thread and heat set. Number one, it stinks too bad. Here's the first test of ASA. Here's the KVP ABS. That's the only non-Polymaker stuff I have right now. And here's the main one. And each one of these just pulls over an average. As you'll see, it just pulls over an average from this right here. It takes the 5 here and it just averages it. You'll see right here, pulls an average. So there you go. That's a little insight to the testing. That's how I'm getting the numbers. That's my methodology for getting the numbers. Right, wrong, or indifferent, I don't care. It's what I've come up with. I designed and built my machine. Now, I had the first machine at 3D Printopia, and this lady came up to my booth that was a materials scientist, and she grabbed a notepad and she started writing down notes and telling me what I needed and how I needed to do it and what to use to drive it. That's how I wound up with the closed loop stepper. The couple hours she spent at my booth was just phenomenal. The amount of information she supplied me, overwhelming. But I wouldn't be here without that. I wouldn't be here without Stefan, CNC Kitchen. I'll put a link down below to his stuff. That's where I got the ideas for most of this. I looked at what he built and I made up my own version of it and ran with it. That's how we got to where we are. Now, the next step for this machine here is right now it's running a Arduino, which is great, but it's limited. So here's that's a Big Tree Tech Raspberry Pi 4. We're definitely not using that. But oh, that popped right off there. Here's a Pi 5, 4 gigabyte RAM. So I got to rewrite all of my code, and I'm going to move it over to a Pi 5. And I'm also going to do data collection, and I will collect probably 10 samples per second on distance and load. And then I will be able to add stress strain graphs to everything. But that may be a while down the road because I'm not near as good with Pi as I am with Arduino code. So again, I want to thank everybody that subscribed to this channel. We're getting there. Let's go take a look right quick and see. And there we go, folks. While recording this, hit 5,000 subscribers. So I get a little teary-eyed here because that's awesome, man. I never thought I'd get to 50, and then I got to 500. Never thought I'd get to 1,000, and got a little push right before Midwest Rep Rap Festival a few years back. Got to 1,000, and I don't know what to say. 5,000 is a big number. It's coming from the heart. Thank you, guys. I love you. Keep subscribing. Keep watching the videos. I'll keep doing these. I'm having fun with it. I've got to do something to keep me busy in retirement, and that's coming real soon. So, as always, I love each and every one of you. Peace out.